Okay, I am hoping by now that you have learned a little bit about sampling, and we're going to do a sampling exercise together. But first, I'm going to show you the ropes a little bit. Might not hurt to have pencil and paper to take down a couple of notes. At least you're going to want to write down what the commands are and how exactly how to how to type them out. So anyways, let's see here. We're going to use our old buddy R at REPL.it. So you need to go to REPL.it and log in and create a new REPL and choose R as the language. And when you get here, you're going to upload a file. I'm going to make it available to you, and hopefully you have already downloaded the file, and I'll show you how to upload it right now. And we're going to go ahead and we're going to do some sampling. And we're going to do some sampling with the penny data that you provided. So anyways, the very first thing we're going to do is we're going to upload the penny data file. Oh, you know, one thing I would like to say is this. I'm just going to try to interject this. I don't know how this is going to work, but I would love it if you had pencil and paper, and if before I begin to work with the data, I'd like to see if you could do a quick sketch of what you think the distribution might look like if you had a bunch of pennies. And when I say what the distribution would look like, I'm talking about the distribution of the data. Now, you gave me all the years for the data, but just imagine that we converted all the years into ages, so that a penny made in 2019 would be 1 year old, and a penny made in 2010 would be 10 years old, and a penny made in 2005 would be 15 years old. Okay, something like that. It's 2020 right now. So imagine that we knew the age of every penny that you guys submitted, and I asked you to guess, what do you think all of those pennies would look like in a distribution? And when I say look like in a distribution, I'm talking about a histogram. What would the histogram look like? You don't need to draw a histogram. You can simply just, you know, draw trace the outline of what you think the histogram would look like. But, you know, in general, what I'm looking for is, do you think the histogram would look more like a uniform distribution, or would it be rather random looking, or would it be like would it be right skewed or left skewed or unimodal or multimodal? Anyways, I want you to take a guess and see what you think. Go ahead and make a quick sketch, and then in a second we're going to take a look and see what the data looks like. And I would like you to practice this idea in general. It's always nice to be able to anticipate what the outcome is going to be before you try to solve the problem. That's true when you're solving algebra problems, and it's true when you're graphing data, and it's true when you're solving problems in general. Anticipating the outcome and then checking the actual outcome against your anticipation is a valuable skill to have. Okay, so hopefully you've sketched something real quickly. Anyways, let's take a quick look. So we're going to go ahead and upload a file. I'm clicking on the three dots where it says Files. We'll choose Upload. And I've named the file Penny Years, and I have it in my data in one of my folders on my computer. And I'm going to go ahead and open that and upload it. Now, hopefully that's not going to take too long. Let me go ahead and pause just in case I have to wait very long. Okay, I'm glad I didn't make you wait for that. It actually took me like several tries to upload the file, and then I actually refreshed the page as well. So if you do have any issues uploading the file, you might need to try it a couple of times and might need to do a refresh. Anyways, I've got the data here, and I'll click on it so you can take a quick look. These are all the years. Now, these are years from that a previous class has sent to me, and so this is just my this is my way of demonstrating it. I'm hopeful that I'm going to be able to give you the data that you entered, you know, this current group of students, and you'll be working with that data. Worst case scenario, we'll be reusing this data, but I'd like it if you're working with data that you provided, because that'll be much more interesting than working with somebody else's data. You don't know if it's canned, you don't know if it was manipulated. Anyways, we do have to do a few things to the data. First thing is that there's a real problem in looking at a histogram of this data. The problem is that there's going to be no data at all between like 0 and maybe the year 1900, okay? And then there's going to be a lot of data between 1900 and 2000. So the histogram gets kind of weird. So what we're going to do is we're going to convert these years into ages. And the way we do that is like such. We're going to go ahead and try importing the data from penny. Well, first of all, we're going to go read.csv, and you might want to write this down. And I'm just going to put the name of the file, penny years.csv. And something that I always want to remind you when you're writing a computer program is that computers do not always do what they don't always do what you want them to do. They do what you tell them to do. So if you're even off by a letter, computers are pretty stupid. They will not know what the heck you're talking about. So anyways, let's make sure that we got the uppercase and lowercase and everything spelled perfectly correct. The other thing is that when I go to look at this file, right now it just starts off with 2012. I'm going to go up to the very first piece of data, and then I'm going to hit enter, and I'm going to go ahead and put year as a header. It's known as a header, okay? It describes what the data is. And I'm going to go back to main. And then I'm going to go ahead and I'm going to go comma, and I'm going to tell R that I am loading in a header. In other words, don't treat that top row as data. And we'll say header equals true. Now you'll notice that when I put in pennies, pennyyears.csv, I use double quotes on both sides, but when I put true, I don't. True is actually it's a constant, and it has a value, and whatever that value is, it's important, and you have to write it as capital TRUE with no quotes in order for it to work properly. Okay, so hopefully that worked, and one of the things I always want to encourage you to do when you're writing computer programs is to check and see every step of the way that things are working the way you believe they're supposed to. So let's check and see whether this works. Do we actually load data into, my goal is that we're loading all of those years into a variable called X. And let's go ahead and check it by printing X. So here we go. I'm going to go ahead and hit run. And when we do, I see a bunch of years, yay, and it even tells me which one of the pieces of data it was. Now, if I go all the way to the top, I can see that there is the header year that I typed in there. Okay, now we can begin to work with the data. Now, the problem is that it's years and I want ages. So what we're going to do is we're going to convert the years into ages. And the way we'll do that is we will take the year 2020, and we will subtract every single value in X, which is all the years. By the way, I probably should have called X years. Might have been better. Ooh, maybe I'll just do that and I'll show you good coding practices, okay? Just going to replace all those X's with years. Let's see here. And there we go. So now the code makes a little bit more sense. It's more readable and more understandable. We like that. Okay, so now supposedly what's going to happen is every one of these years in the variable years, we're going to do 2020 minus that, and that'll be stored in another variable called ages. And again, we can test the variable ages by printing it. So I'm going to go ahead and say run. And hopefully I get if I go all the way down to the bottom of my list, hopefully I see a bunch of ages, and it looks like I do. Yay! The magic of computer programming. Now, if I ever get sick of having to scroll through all this data, in REPLID, I can go ahead and click on this clear button over here, and then I can just run it, and then you can see I go directly to the ages. So yay! And I don't even need to print the years anymore because now I know that it's working. So I'm going to put a little hashtag in front of print years, and that hashtag just says don't run that line. So I'll clear my console screen. By the way, this black area is known as the console, and I'll go ahead and run, and now I only see the ages and no years. Now, it's not true that I only see the ages. I also see these numbers over here, and in a minute we're going to have to do something about that. By the way, I think I can make it so I only see the ages if I do ages $year, In other words, I tell, not years, don't correct me, Replit, just year. If I do print ages $year, I think what's going to happen is I'm not going to get all these numbers off to the side. So let's give it a try. Let's see if it works. Oops, I better clear this out, and we'll hit run. And okay, it looks like a bunch of other garbage, but I will tell you that from my experience, this tells me that now I just have years in ages. I no longer have that extra 1, 2, 3, 4, 5. Okay, so now we can begin to do some math with the data. And one of the things that we want to do, because we're studying the idea of sampling, is we are going to go ahead and take a sample. And R has a built-in sampling function. So we're going to go ahead and go print sample, and we're going to sample from ages $year. And we're going to sample 20, we're going to take 20 of the ages at a time. And I'm printing it because I want you to see that it actually works. And I'm going to go ahead and stop printing. I'll put a hashtag in front of this print for all of the ages. I don't need to see them anymore. I just want to see the 20 that I'm randomly sampling. So I'll go ahead and hit run. Oh, and I'll clear all my console so that we can just see the 20 new data points, and there they are. Now you're going to try this on your own, so you don't have to take my word for it that it's working, okay? Now, the other question is this truly a random sample of all the ages from the data that you gave me? Well, it's a good question. Let's go ahead and run it again and see what happens. Here we go. And I'll run it again, and I'll run it again, and I'll run it again. And it sure looks like it's coming up with different numbers. And of course, you're going to try it on your own, and you'll see you'll get different numbers as well. Now, something that's kind of interesting is that the idea of whether it's sampling with replacement or without replacement. For those of you guys that remember from previous math classes, when we talk about probability, we're always concerned about if we're going to like draw a card out of a deck of cards, do we take the card and replace it, or do we take the card out and not replace it? If we take the card out and we put it back in the deck, that's called with replacement. And if we take the card out and we don't return it to the deck, it's called without replacement. Well, we're going to do without replacement. So we're going to pull out the 20 sample ages, and we're not going to put them back in, not for this sample. And the reason why that's important is because if we did it with replacement, then every single age that we took out, we'd be putting it back in before we take the next one, even when we're taking these 20. And we don't want to do that. We want to make sure that we're getting 20 ages out of our mini population as a sample, and we want them all to be different ones. We don't want to accidentally get the same one over and over again. And remember, this is sort of related to like surveying or sampling in the real world. And in the real world, we wouldn't want to give a survey to the same person over and over again. That would be ridiculous. Okay, now, what other kinds of things can we do? Well, I almost forgot, and I want to do this before we go any further, before we do any more sampling. Remember I asked you a minute ago to make a little sketch of what you think the distribution of ages might be? Well, now we're going to check and see what it actually is. And we're going to do that by doing a histogram. So we're going to do hist, and we're going to do a histogram of the ages. And I can't remember whether I need to do the $year or not. We're going to try it with the $year. And let's go ahead and take a look at what the histogram of the ages looks like from all the data that all of my current students gave me. So here we go. So I'm going to go ahead and hit run. And here is the PDF file. Let's take a quick look. Ready? Drum roll, please. Bam! That is what the histogram looks like. Okay, so I would imagine, from my past experience, I would say many of you were guessing that maybe the distribution was going to be normal distribution, or maybe it was going to be left skewed, or maybe you thought it would be right skewed, but maybe you thought there'd be a little bit more like smaller columns to the left of the big column, or maybe you thought it was going to be uniform, or maybe you thought it was going to be random. I find a lot of people are surprised that the distribution looks like this. And I have to tell you that this distribution is to be expected. And I'm not going to say why, but I may have you folks discuss this in your breakout rooms. So anyways, that's what the data currently looks like. That's what the distribution of ages looks like. Now I apologize because this video is going on, and I'm hopeful that we're getting near the light at the end of the tunnel. Okay, so we're getting there. So the next thing we're going to do is we're going to go back and we're gonna do more printing of the samples. I'm going to go ahead and just move this up because I want to focus on the printing of the samples. But I want to do something else. Aside from just pulling out 20 of, and by the way, when I told you that it pulls out 20 without replacement, that's each time I run the sample command, the thing that you see right here. Okay, when I run the second sample command, it's all the original data again. Okay, and when I run the third, if I run it again, okay, it's based on all the original data. But when I say sample 20, each of these was pulled out without replacing. Okay, but when I run the sample command different times, it's always all the original data. Okay, not with data pulled out, and it has to be that way because I'm going to do this over and over again, and I only have like, well, however many years you guys gave me. I'm not going to be able to pull out a bunch of data. I'll end up with nothing. So anyways, so we are anyways. I'm going to keep going. So let's take a look at the next thing we want to do. We'd like to find the average value of these years. So I'm going to go ahead and find the mean, and I'll have to go all the way to the end and add a closing parentheses. And let's go ahead and run and see what happens. So now instead of getting 20 ages, I just get the average of the 20 ages that I sampled from the population. Now, the thing is this, some of you might be wondering, and I like the idea of letting you do this on your own so that you can see that I'm not making something up, because the end result is so magical. It's important to me that it's not just a demonstration, that you actually live this. So I'm going to go ahead and hit run and just show you that, you know, every time I'm doing a different sample, so I get a different average. And I want to point out that the averages vary. Now, there's something that's very interesting about this because, again, this is an analogy for like doing a survey on a large population. We can expect that if we sample from a large population that we will get varying results. There will be variability. We expect that. So anyways, let's keep going. The next thing I'm going to do is I want to do this process over and over again. I want to point out that what the computer's doing right now is it's pulling 20 sample ages from our data, from the population, and then it's finding the average. And every time I hit run, it's doing that again. And I have to say, I think it's pretty impressive that it can randomly select 20 ages and then find the average of them and do it that quickly. We're going to do more though. We're going to use a command called replicate. And in replicate, I can tell the computer to do this over and over again. Again, I'm going to have to add another parentheses on the end for the replicate command, but I'm going to tell the replicate command to go 10 times and do this. So I'm going to go ahead and hit run. And when I do, now these 10 numbers that you see here are no longer ages. These, well, they are ages, but they're average ages from samples of 20. So what's happening here is we sample 20, and then we sample 20 again, then we sample 20 again, then we sample 20 again, 10 times, and every single time we find the average, and this is our list. And again, if you want to kind of verify it, you can hit run again and again, and you'll see that you get, you know, different groups of averages. So we are getting different averages every time. Again, to me, I find it kind of fascinating. The computer can randomly choose 20 samples, find the average, and then repeat that 10 times, and it does it all in the blink of an eye. But let's make it go a little, let's make it do even more, because one of the beautiful things about computers and automation is that we can get a lot of work done with a little bit of effort. So I'm just going to tack 1 0 onto the end and make the computer do this 100 times. So I'm going to go ahead and hit run. And now what we see is we've sampled 20 ages from the population, and we found the average, and we did that 100 times. And here's all the averages. And if I hit run, it'll do it again. And if I hit run, it'll do it again. And again, I want you to play around with this on your own to see that it actually works. Now, to me, again, it's amazing that the computer can do all that so quick, but we're going to do even more. I want to try it 1,000 times. So I'm going to go ahead and hit run. And boom, in the blink of an eye, the computer samples 20 ages from our original group of data, and then it finds the average, and it repeats that process over and over again 1,000 times, and it does it in the blink of an eye. Amazing, I think. I think at one point in the past I told you that there's an old saying that that if the technology is sufficiently advanced, it's indistinguishable from magic, okay? That's what this is to me. Okay, so anyways, so now we've got a lot of data over here, and basically what we've done is we've just sampled again and again and again. Now again, remember what I told you is that every time we run the sample command, we go back to the original data set. So because if I had to do this 1,000 times and I was pulling out 20 pieces of data every time, I would have run out of data a long time ago. So each time I run the sample command, it's on the original set of data. Anyways, now I have all these averages. The problem is I don't know what the heck is going on with all these averages. This is one of the reasons why we use data visualization when analyzing statistics, because there's just no way to see what this data means. Now, what I'd like you to do, again, is I'd like you to take out a piece of paper and I'd like you to draw a little sketch of what you think a histogram might look like if I took all of this data and threw it into a histogram. In other words, we now have lots and lots of samples that we've taken from our original population, you know, sample, 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 and the samples are always randomly chosen from throughout the population over and over again, and every single time we get an average, and now those averages are going to be in a histogram. So how do the averages stack up, you know? Are the averages going to be left skewed? Are they going to be right skewed? Are they going to be uniform, normal, random? You know, what happens when we do this over and over again with these averages? It's kind of interesting. It's kind of important. So anyways, I'm going to leave this as a cliffhanger, because now you know everything that you need to do to analyze this data. And the one last thing that you're going to do, and I'm not going to do for you, is you're going to replace this print command here with the hist command. Now, one of the things I'm going to ask of you, I'm going to ask that you take a screenshot and you turn it in. And so to make this a little more personal, we're going to tack on when we replace the hist command, we're going to tack on right between the two last parentheses, we're going to put a comma and then main and then equals and then double quote, and then we're going to put your first name and last initial. So for me, it would be Michael W. Okay, and I want you to do the same thing with this histogram, and to me that'll just make this a little more personal when I'm looking at all of your histograms. Let's see here. I'm going to go ahead and put comma main equals Michael W with double quotes on both sides of Michael W. Same thing down here. Now, when you run this, you will now get two histograms in the same PDF, and both histograms should say Michael W, or your first name and last initial, and then you're going to take a screenshot and you're going to upload, and I'm probably going to ask you guys to discuss with the results that we got. Anyways, this video was a marathon. It's long. I apologize for that. Anyways, hopefully you guys will get to work, try to get this done, and I'm hopeful that you are amazed by the results. Let's see.